Welcome to next session on Arduino based systems, and in these next few lectures we will have a detailed study of microprocessor architecture. Microprocessor architecture is the basic theme of the entire subject Arduino, especially when the fact is that the Arduino is nowadays being used by high school going children for projects. If we simply get acquainted ourselves with doing that, it's of no use. Therefore, we must have an entirely new approach of looking at the subject. We must the high school going children, when they work on Arduino, they understand what happens. Whereas when we at an engineering degree education level go through that thing, we must know how it happens. So the very basic microprocessor architecture is very important to be understood. I am aware that it is not only electronics computer class, it is civil, mechanical and electrical class at present to a large extent. So from that point of view, what I am trying to do is, I am trying to give somewhat simplified but appropriately detailed description of microprocessor. So memory block, we spent a lot of time. We spent a lot of time of master servant scenario, wherein how microprocessor instruction execution flow takes place. Then in the last lecture we had said that a single byte memory cell is there, it is a read. So what different memory cells we have? A single byte, a bit, that is read-write memory cell. Then when it is a single byte read-write memory cell, it is having only 8 lines, and whatever is written into that or whatever is to be taken away from that is only accessible through data lines, and that is accessible to the microprocessor. So unless that location is referred, what is there is not known to me as an individual human being. Therefore, if I want that to be useful, then we are having a single byte input port where pins are there, or instead of port you can use input location, because port is a what we can say scientific word. Similarly, a single byte output port or location. So this is entirely memory organization. 16 address lines, 8 data lines. Address lines are input lines to memory block. Data lines are bidirectional. We can have what we can have, if we can enlarge, we can have, so what we can map inside is decoder we have discussed. So for a decoder, we are having, what is structure of the decoder? Structure of the decoder is, it is having n input lines. I think the decoder we explain in short, but in general it is having, I can repeat, n input lines, 2 raised to n output lines, and 1 enable bar line. 1 enable bar line. So suppose if it is having A15 to A0, obviously power supply lines we don't show anywhere. It is expected that now everybody has very clearly understood that supply lines are always there. What is always is normally, that is, you being students, it is expected that always you should study, so you normally ignore that. So it is A15 to A0 as input lines, address lines or select lines. En bar is enable bar, and it is having Y 65,535 bar. Oh, sorry, I should draw it in reverse manner. It is having 65536 output lines. So Y0 bar to Y65535 bar. Since expressing in binary is bulkier, we may express in hex also. So Y0 bar, this decimal is something which doesn't give proper understanding sometimes. So Y0 bar to YFFF bar. So there are 65,536 output lines. There are 65,536 output lines for a decoder. When A15 to A0 are all zeros, this output line goes low and all other output lines are high. So it is n as to 2 raised to n decoder. For n input lines in binary case can have 2 raised to n combinations. So for one combination of the input select lines, that respective output select line becomes low and all other output lines become high if this En bar is low, and if this En bar is high, means if this En bar is high irrespective of A15 to A0, in case of outputs, all outputs are high, that none of the output is selected. None of the output is selected. So A15 to A0 and En bar. If En bar is 0, depending upon A15 to A0, a particular output line is selected. Means it goes low, others go high. With this now, the memory organization of microprocessor, which is connected to microprocessor, what we can have, we can look at a bigger picture where, see, remember, everything of this is to be looked at our mental plane. So the question whether how 65,536 lines will the circuit be bulkier, there is no need to think of that. In today's technology is so advanced that whatever we think should be difficult is much easier to implement. Earlier it was reverse. Thinking was considered to be easy and implementation was considered to be difficult. Now the technology is so advanced. So there is an internal decoder 16 as to 2 raised to 16. The address lines come here. This decoder's En bar we enable it because now there is no need to go beyond this. So we keep it enabled, this En bar. And there are Y0 bar to YFFF bar. There are 65,536 output lines. To using each of these output lines, then how many single byte memory cells can be interfaced here? Obviously 65536. 65536 single byte locations can be interfaced. Each single byte memory location, or now since I am including IOs also, we call it a location. Each single byte location is having what? Each single byte location is having? Each single byte location, when we connect to microprocessor A, it is having 8 data lines, obviously, and it is having read bar sometimes one may not have it, one of them. So A data lines are connected to data lines of microprocessor, read bar to read bar, write bar to write bar, and its chip select bar. Each chip select bar is connected to one of the output lines of this 16:64K decoder, or 16:64K or 65536 decoder, so that for given address, out of these number 0, number 1, number 2, number 3, number 4, number 5, number 6, number 7 till number 65535. So for each address, one location is selected. So if that is a memory location, then all D flip-flop and all that is inside, so nothing comes out. Nothing comes out. There can be, as we discussed, an input port. When there is an input port, it is also having CS bar. Each must have CS bar. The user can connect these input pins I0 to I7, and that appears on B7 to anyway, just by drawing it, I have to maintain some sequence. When it is having read bar, it doesn't have write bar. So whenever an input location is mapped, whatever user puts here using pins, when microprocessor reads that location, means to some of the output pins of this 2:16 decoder, this CS bar is mapped. So when I read that location, whatever user has put comes here. Similarly, there is an output location. In case of output location, the output lines, and there is a write bar. Obviously CS bar, and a supply is obvious, and again D7 to D0 and O7 to O0. So whenever microprocessor writes into this location, these pins become 1 and 0 as the case may be. So read write cell, input location, output location. Now read write cell. So when we say read write cell, we have to write, then that is available. Can there be something pre-written? In that case, there may be such input ports. The pins have come out, but the pins may not come out. The pins are inside and put to some hardwired 1 or 0, which can be changed by some other technique. So this is an input location, as well as if these come out, and if these don't come out and remain inside, with option with the user to hardwire it to either 1 or 0, then it can be said to be read only memory location. Read only location. Read only location. So those who are having vocational 12th, they might have gone through two types of memories. One is said as RAM, and they say that ROM. So whether RAM means, they say that there is a RAM and there is a ROM. I would like to ask a question, whether RAM and ROM are opposite to each other? Means the way in which it is told is something is RAM or ROM. What RAM is? RAM is random access memory, and what ROM? Read only memory. Why? So what is, I give a question, you can pause, think, and if you are able to think, it's good. If not, then continue and watch. What is the opposite word of RAM? RAM is random access memory. RAM is random access memory. What is opposite word to that? And what is ROM? Read only memory. What is opposite word to that? Those who want to think should pause, think for a while, and then continue. So the word opposite to RAM is SAM, is random access, whereas you may be aware that some kind of cassette is sequential access memory, where access time depends upon location, whereas for RAM access time is uniform. And instead of read, only memory. The opposite word of the opposite of RAM is SAM, and opposite of ROM is read write RWM, read write memory. So somehow accidentally we think that RAM and ROM is opposite feature. It's not like that. So this is what we can say. In general, now there are 4 types of memory locations. One is read write memory, one is input location, one is output location, and one is ROM location, which is like input location, but the pins are not come actually out to the user, but they are there, which the user can program through different method, and that gets stored. So what is the difference? Whatever we write into read-write memory using microprocessor's write commands, selecting that location, that is stored in that particular location as long as power supply is there. The moment at which power supply goes, the content stored in the read-write memory location, read-write location disappear. Then the word disappear is very odd in microprocessor. What we mean by disappearing? In case of disappearing, it is not that it can go somewhere. Only difference is that in case of this one, disappear means whatever is stored is not guaranteed to be retrieved after reset. The contents of every memory location, after reset, the contents of every memory location, which is read-write location, are random and unpredictable. Whereas if it is ROM location, for each of the location there are such input lines. Those are hardwired to either 0 or 1, which you have to do separately, not with actual switches. So that is called as programming ROM. Then now instead of ROM, which is only one factory programmable, there is called as PROM, programmable read-only memory, which you can do on your own. Now all these words are irrelevant with the advanced technique, and now once you program using some technique, you have to erase it using ultraviolet rays, EPROM, erasable programmable read-only memory. So what is difference is that in general what we have to have in this entire memory block, we can interface, means there are total 65,536 locations which can be connected. So of those you can connect some part as ROM, some part as read-write memory, RW, there is no need of, or we can use it, read-write, or we can say RAM you don't use. If you are using the word ROM, then the RAM is random access, means when I say that there are 2 types of memory locations, one is ROM and one is RAM, I am comparing on different footing. That is what you can say, that if you are saying that the grapes are sour and the orange is big. Are you getting me what I am saying? Saying ROM and RAM together, that this part is RAM and this part is ROM, is wrong, because you are saying on different features. Say grapes are sour and orange are big. No. So you must compare on some parameter. Grapes are small, orange is big, okay? Grapes are sour, orange is sweet, is okay. So ROM, RWM, or RAM, then there must be some SAM. So ROM locations, read-write locations, input locations or input ports, and output locations or output ports. So this in all can be 16-bit processor, whatever you can connect from outside is 65,536 locations. In all, you can connect 65,536 locations. Now, we proceed with how this so now a big picture is created of the microprocessor based system, and so 16 address lines, 8 data lines, 1 read bar, 1 write bar. As stated, the microprocessor is having 1 reset bar and 1 clock pin. So the activities are sequenced on clock. We will use 8085 like examples when we take the register names, etc., pins. Those who have learned vocational 12th or those in CSE or those whose parents are in this electronics field should keep it in mind that this is 8085 like. Otherwise when you say, oh what nonsense you are teaching in the class, 8085 does not have separate address and data lines. It is having address data multiplex lines and address line number. All those complex things I am avoiding because learning 8085 is now no longer a skill. I am using that example to just simplify the things, and somewhere if you want some literature reference, you can get it very easily. So I am explaining I'm using 8085 to explain microprocessor architecture. I am using 8085 to explain microprocessor architecture. When I am using it to explain microprocessor architecture, in that scenario, let us talk now about what is there inside microprocessor. Inside microprocessor, there is simply different logic gates connected in a very complex manner, since it is also having some memory in feedback, just like flip-flops and all that. So just like outside locations, inside microprocessor also there are some single byte read-write locations. Inside microprocessor also there are some single byte read-write locations, and the inside locations of microprocessors, the locations which are inside single byte, or sometimes you can pair them into 2. So it would be 16-bit single byte, sometimes paired also, read-write locations inside CPU are called as registers. Just a name given, a register. So there are now what microprocessor is to be studied from application than theory. So what can be connected to microprocessor? A memory block which contains 2:16 decoder, various. So using address lines, data lines, read bar and write bar coming out from microprocessor, where data are bidirectional. So I say coming from microprocessor, we can connect various read-only location or what can be connected from outside to microprocessor is a total group of 65,536 locations, which can be read-only memory locations, read-write memory locations, input ports or locations, output ports or locations. So what is expected out of microprocessor? The working of microprocessor, if it is to be meaningful for user, working of microprocessor if it is to be meaningful for user, must be using input ports and output ports. So whatever is put on input ports for microprocessor, that is user will put. So microprocessor will say some atomized system. Microprocessor will refer that input and 1, 2, there can be multiple bytes. For any byte, any number of input locations you can interface to microprocessor as long as it doesn't exceed 65536. So you can, if you are having say 16 pins, you can use 2 ports. Then depending upon whatever is the combination of these multiple lines, microprocessor evaluates something and outputs something on output line. So for the user, if I am the user, these read-only locations I can't read, read-write locations I can't read, this input ports, so there are few input ports of to microprocessor and there are few output lines coming from microprocessor. So these are input ports. We can only one is sufficient for many applications, and output port. So this is I7 to I0, O7 to O0, O7 to O0. Then what microprocessor will do in an atomized manner is just reading something, reading these, and depending upon the logic which you expect, which you program, microprocessor program for something. So the master in his absence to look after the premises tells servant something, this is to be done when this is there. So that is this program. So microprocessor is supposed to read that. Where is the program? The question, where is the program? Program can't be inside. Program is there in the outside in this read-only memory. Means the master programs servant. The difference is that servant, it is inside servant. Here this together becomes servant. So master, that is user, develops a program and puts it in ROM, which is executed by the microprocessor. For that purpose, for many of the parts, this read-write memory is required, and the main thing is input ports and output ports. So the program will read this, evaluate various options, compute something, very complex calculations, and based on that, output something here. And this is permanent. So a microprocessor based system is expected to read inputs, have exhaustive work, deliver outputs, again read inputs. So that's all. So now the questions are: through the inputs, microprocessor should understand some instruction. So now what we are having? There are various registers inside microprocessor. Then the instruction, something which is coming inside. What comes inside microprocessor is only through data lines. So what can come inside microprocessor is only ones and zeros. That ones and zeros must be decoded to something. So that hardwired logic must be there. That is called, one of the registers is called an instruction register or instruction decoder. One of the registers, which is main register, is called as instruction decoder. Then there are various, I will use small space here. There are various general purpose, I will explain to you in a very systematic manner how things work. There are some internal memory locations, read-write locations that we call the registers, and we use for 8085 accumulator A is a register, also some special functions takes place. Then B, C, D, E, H, L. There is one more register, pairing accumulator, that is some bits are important, is flag register. These are the registers inside microprocessor. These are general purpose registers. General, just names. Some name is to be given to identify, so that name is there. Now, what microprocessor should do after you reset it? So you reset bar means reset bar is made 0 and then it is made 1. So microprocessor starts functioning. Microprocessor starts functioning. So when microprocessor starts functioning, what it should do? Just like I have told you that a mischievous student who is carrying copy, that after going to exam hall I have to bring out the cheat from the front pocket that must be embossed in him. Like that, once that is embossed, that is executed, what next is written there? But what first? Can't be written anywhere. What first must be embedded within. What is the first thing to be done must be embedded within. So after reset, so what microprocessor can do now? With respect, I am looking at, this is microprocessor based system. So this is the user. But if I look only microprocessor, then this is our external. So with reference to external world, what microprocessor can do? Address, data and read bar, reset clock. So a 3 clock cycle is a machine cycle. Again, those who have had an exhaustive study should not please try to correlate that. I am having simplified assumptions. So once microprocessor starts functioning, the clock, so again this convention, from low going age of clock to next low going age of clock is called as one clock cycle. Is called as one clock cycle, and microprocessor completes one operation. One operation means what operation microprocessor can do? What microprocessor can do is very limited. Microprocessor can either execute a read cycle or a write cycle. Read cycle means what? Microprocessor will read from where to read. So it will output some given address, fixed address on address line. So the 3 clock cycle comprise one machine cycle. So microprocessor will put one 16-bit address on address lines in the first clock cycle in T1. In T1, that is first clock cycle, then second clock cycle, third clock cycle. In T1 it will put address out. In T2 it will make read bar low and it will capture, and in T3 it will not do anything, prepare for next cycle. So there is why there should be 3, there is no significant justification, it takes some time. So when I tell something, I pause. Why I pause? Because you should be prepared to listen the next word. So it puts address, it puts read bar. So microprocessor outputs address, microprocessor activates read bar. When microprocessor outputs address and microprocessor activates read bar, that time the external memory interface will select the corresponding location and we'll put the data in that stored in that location on data lines which microprocessor will read, right? So it is a read cycle. And if it is a write cycle, what should happen? If it's in case of a write cycle, what should happen? In case of a write cycle, microprocessor should output address lines. Also means where to write and what to write. So in that case, in write cycle, it address out, data out. Microprocessor puts address on address lines, data on data lines. Then instead of read bar, it's write bar which goes to. That's all, a write cycle. So from the point of external world, what microprocessor can do is a read cycle or a write cycle. Is a read cycle or a write cycle. Read cycle or a write cycle. In case of read cycle, only address is required. In the write cycle, address as well as data is to be provided by microprocessor. Then my address must come out from microprocessor. Address must come out from microprocessor. So how can it come out? Say when I am talking something, and at least there may be a debate that whether what I talk is understood by the students or not, is it meaningful or not. That is debatable, but I think everybody will be guaranteeing that I am not talking something absurd. So whatever is coming on my tongue, it can't come from vacuum. It must come from something within me. So like that, in case of a read cycle, the address is a 16-bit combination is appearing on address lines. These pins of microprocessor are becoming 1 or 0. So that must be given by something which is inside microprocessor, which must be stored inside. So some register pair will give address. Then it gives address and microprocessor activates read bar. So I ask you a question, you answer. Then based on that evaluation is there, so I must record it somewhere. In read cycle, some register pair means for every read cycle there may be not same pair, some register pair will be sequenced properly. Some register will give address and then data is available on data lines. Data available on data lines will be stored in some register. That is 8-bit. It is not register pair because data is 8-bit. It will be stored in some register. So I hope that I tried my level best. This is for read cycle. For write cycle, what should happen? You can put a pause, you can think on your own on likely happening and then you can verify. In case of write cycle, I will say address should come some register pair. Some register pair will give address. Some register, not pair now because it is 8-bit. Register will give data and write bar with activity. So if ever if we have to write, if we have to sequence the activities, now I will put it on the left hand side with small thing, or there is no need also, but since you should not forget it immediately, I am just writing it, putting it here. CPU and memory block. Address, data, A15 to 0, D7 to 0, read bar, write bar, reset bar, CLK. And in this memory, read, write, ROM, RAM, input ports, output ports. And that ports come out. Input port and output port. Say for example I7 to I0, O7 to O0. Now, how we can have the microprocessor cycle diagram? How can we have microprocessor cycle diagram? We can have microprocessor cycle diagram in a very simple manner. Address lines, data lines, that's all. Now, so when it say address lines, what we should provide? Which register pair gives address? In case of and type of the cycle, we can write here. First type of the cycle, type, that is read or write. Then who gives an address, comes from where? Address, who gives, and data, either who gives or where it goes. Now, type of the cycle, type, read or write, that's all. Now we proceed. So you have just reset the microprocessor and come out. You just reset the microprocessor and come out. Then after reset, what should be the first cycle? It should be read cycle or a write cycle. Microprocessor can undertake any cycle, either read cycle or write cycle. If it is read cycle, some predefined register must give address, some predefined register must give data. And if it is read cycle, only some predefined register should give address, data will come, that is to be something is to be done with the data. If it is write cycle, then some given fixed register, some predefined register will give address, some predefined register will give data, and that is to be written. So after reset, whether the first cycle should be a read cycle or write cycle. You can put a pause, think, because it's a very fundamental question. You can think and then you can again resume. After this, if it is a write cycle, in that case, if it is a write cycle, in that case, it is microprocessor has to give data, it has to give address, also it is to give data. Microprocessor has to give address, also microprocessor has to give data. Both are to be given by microprocessor. If it is read cycle, then it is microprocessor who should only give address and data will be given available to it. So after reset, the first cycle, if ever microprocessor is to be like something which is different than conventional digital circuits, something which is programmable, logic, programmable device. After reset, some register can give address, some register can give data. But after reset, it must be predefined and fixed. So after reset, the first cycle is write cycle. What will happen? Microprocessor, some register gives address, some register gives data that gets stored somewhere. Then what? What should be? Means after the question is after reset, what should be the first cycle? If first cycle is a write cycle from some fixed address and from some address coming from somewhere, some register, data coming from some register, then that is over. What should be the next cycle? If first cycle is a write cycle, the question still remains, what should be the next cycle? If that is again the write cycle, then next. So unless there is a read cycle, then what next cycle is can be depends upon what is available to you. So after reset, it must be a read cycle. It must be a read cycle. And address, there is one register pair inside microprocessor that is called as program counter. PCH 8-bit plus PCL 8-bit together, it is a program counter. So it is program counter which gives address. Program address given by program counter. So it is no need to program counter giving address, and data will go. Then after reset, it must restart from a fixed location. So after reset, program counter becomes, in this case, 0000 hex, all zeros. So after reset, program counter becomes 0. It reads the first cycle after reset is a memory reads, is a read cycle from address 0, and data comes. That data should tell microprocessor what it should do. So that data must go to instruction register. So address coming from program counter and data going to instruction register. So this in read, I am reading. In this read, I am reading the 8 bits as instruction. So this is also called as a read, but a specific, that is opcode fetch cycle, or it is called as F cycle. So F is read for instruction reading, read for operation code reading, and normal read is, so there are 3 cycles. Actually there are 2 only, read or write, but when I am reading it as an opcode, it is called as fetch cycle. So there are total 3 cycles. Read, to be very precise, in fact meaningfully there are only 2, it is read and write, but in that read there is one special called as fetch, then normal read and write. So the first cycle is put as a fetch cycle. I now put FR or fetch. Then that data goes to instruction register, and then depending upon its combinations, it tells microprocessor what next cycle should be. So based on what you read in the first cycle, what next cycle is to be told, and that we shall continue in the next lecture. Thank you.